Hi, I am Jeanne Dominique Paloma from STEM D11.
I am Aldrich Baynas from Group 4.
I am Mitch, Vaness, Legaspi from STEM FORTITUDE.
And we are Group 4D. So we will be talking about higher order derivatives. What are higher order derivatives? The process of differentiation can be applied several times in succession, leading in particular to the second derivative, f double prime of the function f, which is just the derivative of the derivative of f of prime. So, higher order derivatives is the derivative of a function beginning in the second derivative. Now that was a lot of derivative. Here's some examples.
So in this video, we will focus on getting the higher derivatives of this given function. So let us have f of x equals 3x raised to 5 plus 2x cubed minus 6x plus 4. And let us find the second derivative of this given function. So let us have 3, then the derivative of x raised to 5 plus 2, then the derivative of x cubed minus 6, then the derivative of x plus the derivative of 4. So to simplify, let us have 3, then the derivative of x raised to 5 is 5x raised to 4 plus 2, then the derivative of x cubed is 3x squared minus 6, then the derivative of x is 1, and then the derivative of 4 is 0. So to get the first derivative, let's have 3 times 5 equals 15x raised to 4 plus 2 times 3 equals 6x squared minus 6 times 1 plus 0 equals 6. So this is our first derivative. So to get the second derivative, let us have 15, then the derivative of x raised to 4 plus 6, then the derivative of x squared minus minus the derivative of 6. So to simplify, let us have 15, then the derivative of x raised to 4 is 4x cubed plus 6, then the derivative of x squared is 2x minus the derivative of 6 is 0. So to get the second derivative, let us have 15 times 4 equals 60x cubed plus 6 minus 2 equals 12x minus 0 equals 0. So this is our second derivative. So in this example, we need to find the third derivative of the given function, that is f of x equals square root of x. The first thing we have to do is we will rewrite the square root of x into exponential form, then that is x raised to 1/2. And now, we will get the first derivative. The derivative of x raised to 1/2 is 1/2 x raised to 1/2 minus 1. And to simplify, let us have 1/2 x, and 1/2 minus 1 is equals to negative 1/2. And this is our first derivative. And to find our second derivative, let's have 1/2, bring down negative 1/2 x raised to negative 1/2 minus 1. To simplify, let us have 1 times negative 1 is equals to negative 1 over 2 times 2 is equals to 4 x. Negative 1 over 2 minus 1 is equals to negative 3 over 2. So to find the third derivative, we'll have negative 1 over 4, bring down negative 3 over 2 x raised to negative 3 over 2 minus 1. So to simplify, let us have negative 1 times negative 3 is equals to positive 3 over 4 times 2 is equals to 8. 8x. Negative 3 over 2 minus 1 is equals to negative 5 over 2. And to eliminate negative sign in the exponent, we will have 3 over 8x raised to positive 5 over 2. So we will write this into radical form, and that is 3 over 8 square root of x raised to 5. Since the index is 2, we will divide x raised to 5 into 2, and that is 3 8 square root of x squared times x squared times x raised to 1. That's the total of x raised to 5. Now, 3 over 8. How many x squared do we have? And that is 2. So, 8x squared square root of x. And if you want to rationalize this, we will have to divide both denominator and numerator by square root of x. And we will have 3 square root of x over, let's cancel this, 8x squared times x. So come up the answer 3 square root of x over 8x cubed. That will be our answer.
Find the third derivative of 10x5. So this equation is commonly known as theorem number 3. So first we will find the first derivative of 10x5. So since 10 is constant, we will take it out and find the derivative of x5. We will use the theorem 2. So 10 times 5 is equal to 50. So this is the first derivative of 10x5. Second is to find the second derivative of 10x5. Since 50 is constant number, we will take it out and find the derivative of x4. Same as procedure 5, use the theorem number 2. So 50 times 4 is equal to 200. So this is the second derivative of 10x5. So last is to find the third derivative of 10x5. So since 200 is a constant number, we'll take it out and find the derivative of x3. Same as procedure, use the theorem number 2. 200 times 3 is equal to 600. So this is our final answer. The third derivative of 10x5.
So we're going to find the formula for the nth derivative of 1 over x. So first, we're going to bring up x, so that would be f of x is equal to x to the power of negative 1. So we're going to take the first derivative. F prime of x, which corresponds to n is equals to 1. So using the product rule, we're going to find the derivative. That would be negative 1 times x to the power of negative 2. For the second derivative, f double prime of x, which corresponds to n is equals to 2, is equal to, since both are negative, we're going to get a positive 2. That would be 2 times 1 times x to the power of negative 3. Third derivative, f triple prime of x, which corresponds to n is equal to 3, is equal to, bring down negative 3, that would be negative 3 times 2 times 1 times x to the power of negative 4. Fourth derivative, fourth prime of x, n is equals to 4, is equal to, both are negative, so we have positive 4 times 3 times 2 times 1 times x to the power of negative 5. Now we didn't multiply these 2 times 1, negative 3 times 2 times 1, so that we can see the pattern. So we can find the formula. So the nth derivative of the function is equal. So first, let's deal with the positive and negatives. So here we can see that this is positive. Here we can see that this is negative. Here positive, here negative, and then here positive. So it looks like when n is an even number, we get a positive number. Here n is even, then we get a positive number. Then if n is an odd number, 1 and 3, we got a negative number. So we can assume negative 1 to the power of n. So when n is odd, we're gonna get negative 1. And when n is even, we're gonna get positive 1. So next, here, all of these, we can bring this down. So this would be 1 over x. This would be negative 1 times 1 over x squared. And same goes for the others. And we can also notice that it is 1 higher. And when n is equals to 1, we got 2, which is 1 higher. When n is equals to 2, we got 3 plus 1 higher. Then we got n is equal to 3, we got 4, n is equals to 4, we got 5. So this is gonna be x to the power of n plus 1 since it is 1 higher. So what about the top piece? The top piece here seems to be a factorial. Here, 1 factorial is equal to 1, 2 factorial is equal to 2, and 3 factorial is equal to 6. So the top piece is gonna be n factorial. So this is the formula for the nth derivative of the function 1 over x. So that ends our presentation for higher order derivatives.
Thank you for watching!